Hello everyone and welcome back once again to Newegg TV. My name is Paul and we have a special guest who has returned after much trials and trepidation. None other than JJ from ASUS, one of our favorite guests here on the show. And I have a new nickname for him. We're going to call him Dr. ASUS from now on.
Sounds good, boss.
Sounds good. All right, so JJ is here to celebrate the launch of the long-awaited, what's been codenamed Haswell up to this point, the 4th generation Intel Core processors. And of course, ASUS has a whole slew of motherboards. This is just a portion of them that we have here in front of us. But what we wanted to start out with was maybe just a little bit more to familiarize our fans and our audience with what this platform is all about. Some changes going from the Z87 socket 1155 platform to Z87, which is a new chipset, the 1150 socket. So what would you say are some of the key points that folks should bear in mind when they're going from the one platform to the other?
You know, there's actually a lot of them. You know, I mean, I think every time that we have kind of one of these platform introductions and we have a lot of these motherboards that we're going to be covering, we try to always emphasize that you should be treating this as kind of an entirely new experience. There's definitely points where you're going to want to help to compare it against what might exist in the ecosystem, such as like, you know, where does maybe this sit in relation to X79, or where does it sit in relation to the previous generation? But you still always kind of want to evaluate what improvements might be coming down the pipe specific for this platform and how it's going to coincide with your usage model. But in terms of what we're seeing, there's going to be a lot of things that are very similar. You know, as you noted in terms of the socket itself, there's not really any big changes. So for you guys out there that don't like having a socket change that requires you to maybe have a different backplate or a different type of heat sink or a different CPU configuration altogether, you don't have to worry about that. It's entirely the same thing. You're still utilizing DDR3. It's still the same form of Sata connectivity. But what we have seen is a lot of revisional changes to aspects of the PCH, so the platform controller hub, which does influence not only USB 3 connectivity, but SATA 6G connectivity. But we're also seeing changes to the CPU in itself. This being the 4th generation, as you noted, Core Series processor. Intel has continued to, of course, refine and change the architecture. And there's some pretty drastic changes that we have for this generation on the CPU, not only in how it's been designed and what's implemented in it, but how that influences even aspects of our board design. Okay, so things that are staying the same, so to speak. You have the same mounting system, so if you have an existing aftermarket heatsink fan, or if you have a closed loop cooler or something like that, you will be able to carry it right over from just about any socket right now. Most of them are compatible with all of them, but 1156, 1155, and now 1150, all the same mounting solutions, so that's fantastic. Same DDR3 memory standard, so you can use your same system memory. New socket in itself, so you will need a new motherboard if you do go to the Haswell system. As opposed to the previous generation, you were able to take Ivy Bridge and you could run it on the previous generation, let's say motherboard. That won't be the case here. The socket physically in terms of the CPU support is different, so it's exclusive to only being supported of the Haswell or the 4th generation Core Series CPU. So don't try to take a Sandy Bridge or Ivy Bridge processor and put it in a socket 1150 socket, because it just won't work. But we do have some pretty awesome changes with the chipset you're mentioning. So USB 3.0, we've gone from native, I'm sorry, was it 2 or 4? 4 ports. It was 4 ports. I should have known that. 4 ports with Z77. Now with Z87, we have 6 ports available, and those are native. Of course, a board vendor has the option to add more USB 3.0 connectivity if they so desire, and ASUS has done that with several of the boards here. We also have the SATA 6G connectivity, and this is one that I'm really excited about. If you guys have been working with SSDs at all, a lot of those, if you try to connect them to a SATA Rev 2, which is a 3 gigabits per second connection, you'll actually bottleneck the SSD. Now we have 6 of them available. All of them have RAID functionality. And is there anything else connectivity-wise that Intel has done with the PCH as far as the SATA connectivity? No, for the most part, that's pretty much going to be, you know, what's changed there fundamentally. You know, there is a bit of a transition in some of the specification that Intel is promoting, such as mSATA. We do have only one solution that will actually be utilizing mSATA because we have updated actually to a new specification called M.2. That being said, for some people that still might maybe be utilizing an mSATA-based solution on our WS series, because the mSATA port is linked into the PCH, you now have the benefit of mSATA being linked into a SATA 6G lane as opposed to being linked into a SATA 3G lane. So if you did purchase one of the late generation mSATA SATA 6G solutions, for this platform you'll at least be able to fully realize the performance throughput and the actual maximum performance metrics for that type of solution. And that's an excellent update. I've used mSATA SSD with quite a few different boards, and pretty much
Prior to now, if you really wanted that SATA 6G connectivity, you really either needed an adapter card or you needed to basically connect to a notebook or something that had it natively wired in there. So another great option there. We have a quick slide, so let me pull that up just so we can get a nice visual representation here. We can also double check the points that we're going over. So we also have a new integrated GPU as part of the processor. So what sort of added functionality do we get there?
It's fairly minimal, actually. Intel's done a huge amount of work with this CPU platform to be able to usher in an entirely new level of graphics performance. But as you know, we're dealing with Z87, so this is a performance-oriented chipset. So the majority of you guys out there are going to be interested in running discrete GPUs of some flavor. So in this respect, because of design constraints in terms of thermals and other complex elements at how the CPU is designed, Intel has only phased in their more moderate version of the graphics core. So that's coined GT2 versus the GT3, which you might see maybe actually in some mobile products as well as in BGA form, which might be like in integrated solutions like tablets or things along those lines. So the highest level of Haswell-based graphics are only going to be available outside of the core desktop. But for most of you guys, it's not going to really impact you because, of course, you're going to be running a discrete graphics card. But in addition to that, though, another maybe even bigger change than the graphics update that you'll see, which is going to be fairly minor compared to the previous Ivy Bridge graphics update, is going to be the inclusion of an actual PWM, or as Intel calls it, the IVR.
I see. And so that is actually controlling the power that's delivered to the processor, and that is now another of the, we've had different things. We've had memory controller that's been sort of gobbled up by the processor. We've had Northbridge pretty much entirely gobbled up by the processor. Now we actually have that voltage regulation. Now, just to clarify for some of our viewers out there, you might see, for instance, some of the heat sinks on some of the boards we have out here, and those are actually cooling some of the components that deliver power to the processor. So what would be the distinction between the IVR that's now integrated as part of a fourth generation Intel Core processor versus, say, the power delivery components that you see on the motherboard?
That's actually exactly the difference. What you're going to see in terms of the VRM section of the board or close to the heat sinks is actually going to be the power components. So those supply power to the actual CPU and for the entire CPU level of functionality. That can't be integrated directly inside the CPU package at this point. So pretty much it's just going to be the control flexibility, the management, the regulation, that's going to be handled inside that IVR that's built inside the CPU. So that'll be consistent across all Haswell-based CPUs. So you guys that are familiar have checked out our Newegg videos here in the past covering ASUS product. We've talked a lot about Digi plus VRM. So historically that's been one of our biggest feature points, is having a digital controller. So essentially Intel has now integrated that digital controller inside the CPU to give you an advanced level of control and flexibility at how you manage and tweak and tune your CPU. Now there will still be some digital elements that are left to be responsible for the vendor in terms of execution and implementation. So we'll still have a digital controller for the DRAM that's on the motherboard, and we still have an external digital controller which has to change the actual input to something that can be understood by the IVR. So there is kind of still a two-stage process that occurs, so it's not entirely all being handled by the integrated CPU, but it is a very drastic change, and it will at least allow for consistency in terms of a certain set of feature set and functionality across all the boards because the power management is built into the CPU.
Okay, so a change with the actual design of the Haswell chip, which might be a little bit difficult to grasp at first, depending on how familiar you are with processors and motherboards and power delivery, of course. We will be elaborating on this a little bit more because we will be doing an overclocking demonstration. And these are the elements of the design of Haswell which are really going to play into, particularly if you're going to be doing overclocking with the chips.
Yeah, I definitely agree. There'll be a lot of points that, because of this implementation, it influences all kinds of factors outside of just the architecture itself is different, and every platform is a little bit different. You have to kind of learn how to work with it, how to tweak it, and we're definitely going to take a lot of time here to show you some really cool ways to maximize and overclock the platform on any number of our different boards, and utilizing the IVR as well as, of course, all our power designs and our special designs that help to maximize overclocking performance.
Excellent. And now just to round out our quick overview on Z87, we do have some different ways of connecting displays. We already mentioned the integrated GPU as part of Haswell. Now, as far as the displays that are available, we have now upgraded from 2 concurrent displays available with Z77 and Ivory Bridge or Sandy Bridge, to 3 concurrent displays available with Haswell and Z87.
Yeah, you can support 3 digital display outputs, so that's great, and it even supports the latest 1.4 specifications. So you got a lot of flexibility if you're just looking for basic multi-monitor workflow, or you don't necessarily need something that's going to require a huge amount of 3D horsepower. It's more so for productivity focus. It's going to be a great option that you have integrated directly inside the GPU. And I think tying into GPU is probably PCI Express. A lot of people always wonder, you know, is this platform maybe have more lanes, or is there any difference? But we're pretty much looking at what we looked at in the previous generation. So we have 16 lanes that are coming from the CPU, all Gen 3 enabled. But it being Gen 3, that means that we've got gobs and gobs of bandwidth. So, I mean, keep in mind that essentially 1 by 8 Gen 3 is equivalent to 1 by 16 Gen 2. So, you know, when you kind of start splitting things like that, you realize that you still do have a huge amount of bandwidth available to you. And of course, optimally focused for you guys that are still interested in Crossfire SLI, fully supported here. And it still leaves us enough room with, depending on how we design the boards, to be able to give you a huge amount of extensive connectivity. Some situations might have to maybe include some type of multiplexing solution to also make sure that we can handle more concurrent PCIe lanes. But as a whole, no changes there.
So plenty of PCI Express bandwidth still available, of course, with PCI Express Gen 3. The board vendors, such as ASUS, do have the option to add additional lanes, like you're mentioning, via a multiplexing chip. And then the other part that we haven't really talked about yet was that X79, the enthusiast platform from Intel, still around and
not
still
going anywhere.
viable, not going anywhere. So if you're on X79 right now, fantastic, good for you. And if you really do need tons and tons of PCI Express bandwidth, that's probably going to be the platform to go with.
Yeah, I would agree. If at the end of the day you're interested in maximum bandwidth, maximum connectivity, more cores, more cache, you know, more density available to you even on memory side, right? X79 is still going to win in every single one of those facets.
So for the most hardcore users, don't worry, your enthusiast platform, Socket 2011 X79, still available, still going to be viable for quite some time. But that, I think, is going to wrap it up for this video. So this has been our quick introduction to the Z87 chipset, Socket 1150 processors, which have been known as Haswell up till now. Now they're going to be known as Intel's 4th generation core processors. We've been talking with JJ from ASUS, and thanks a lot for stopping by, JJ.
Thank you for having me.
And if you guys would like to see more videos, we're going to be doing more in-depth coverage of all of these boards here. We're also going to be doing coverage of several of the other ASUS lines of boards, such as the workstation boards, ROG boards, as well as the TUF series boards, which I'm particularly excited to check out. So stay tuned for those. We're also going to be doing overclocking demonstrations, so lots of good content still to come. Thanks for watching, guys. Don't forget to like the video if you enjoyed it, and don't forget to subscribe to Newegg TV. We'll see you next time.